Hello everyone, this is Mr. Jigs and welcome to Jiggy Maths. This time we will be learning about quotient rule of differentiation. Now this quotient rule is used in finding the derivative of a function that is expressed as a division of two separate functions. So in this case, we are finding the derivative of y is equal to f of x over g of x. And what is the rule? The derivative now, which is the derivative of y with respect to x, is equal to g times f prime minus f times g prime all over g squared. Now, since the operation in the numerator is subtraction, so the order matters. So you have to be careful that the first term here must be g times the f prime. Now, for you to be guided in this, you can actually use this mnemonics, as you may say y is equal to high over low. So high is the numerator and then low is the denominator. So the derivative now is equal to low d high minus high d low over low square. So just remember low d high as the first term, and it follows that the second term will be high d low. Okay? Now let's apply the rule in differentiating the first example, and that is y equals 2x minus 3 all over x squared plus 5. So notice that we have a quotient of two separate functions in which we can consider the numerator as our f and the denominator as our g. So recall our rule wherein the derivative of y with respect to x is equal to low d high minus high d low over low square, or gf prime minus fg prime over g square. So take note that it's always the numerator that we differentiate first, okay? So the derivative of y now with respect to x will be equal to, okay, so low d high, meaning copy first the denominator x squared plus 5 times the derivative of f, which is the derivative of 2x minus 3 is 2, minus, okay, so this time we have to copy the numerator 2x minus 3 and then derive or differentiate x squared plus 5, which is 2x, and then all over the square of the denominator. Okay, and then simplify it. It becomes 2x squared plus 10 minus 4x squared plus 6x over x squared plus 5 bracket square, and then combine the similar terms, and this is our final answer. All right. Okay, so now you can also express our given function as 2x minus 3 multiplied to x squared plus 5 to the power of negative 1. So if you do this, then you apply, or you can apply, the product rule instead. Okay, now let's focus on quotient rule. So second example is we are differentiating y equals 2 minus x all over square root of x cubed minus 8. And once again, the numerator is our f and our denominator is our g. Now it is better for us to write our denominator in this form. Okay, x cubed minus 8 to the power of 1 half. Okay, so once again, this is the rule low d high. So differentiate first the numerator, and with that, we have to copy the denominator. So copy the denominator, which is going to be x cubed minus 8 to the power of half. The derivative of 2 minus x is negative 1, minus, this time we have to copy the numerator, and then we have to apply the chain rule to get our g prime, or the derivative of the denominator. So applying chain rule, we are going to have 1 half times x cubed minus 8 to the power of negative half, then multiplied to the derivative of x cubed minus 8, and that is 3x squared. And then don't forget that you have to square the denominator. Okay, so now let's simplify that what needs to be simplified. Negative times x cubed minus 8 to the power of half, and then 3 multiplied to, okay, so that's 1 half, and then that will give us a 3 over 2. All right, or 3x squared times 2 minus x times 1 half, x cubed minus 8 to the power of negative half all over x cubed minus 8, because we can cancel out here the square root and the power of 2. Now let's try answering example number 3. So we need to differentiate with respect to x. Um, y is equal to x minus 1 to the power of negative 1 all over x plus 1 to the power of 4. Now, if you would like to avoid having a negative index here, you can bring it down to the denominator and it will become x to the power of x minus 1 times x plus 1 to the power of 4. Now, let's make the numerator be our f and our denominator be our g. Now, to make it less confusing, what you can do is you can differentiate first the f and the g. So let's find out first the derivative of each. So f prime is equal to 1, and our g prime, since there are two factors involved here, that means to derive this we need product rule. So g prime there is equal to okay, let's derive this. It will become 4 times x plus 1 to the power of 3 and then multiply to x minus 1 plus x plus 1 to the power of 4 times the derivative of x minus 1, which is 1. Okay, so since we have already the derivatives, you can plug this in our formula. So our dy dx now is equal to, what is our g? G is our denominator here, and then our f prime is 1, then minus you copy the numerator and then multiply to the derivative of g, which is this one. Okay, and then all over the square of our denominator, which is x minus 1 square times x plus 1 to the power of 8. Okay, so notice that this is our first term, and then this is going to be our second term, and the negative x times x plus 1 to the power of 4 will be our third term. All right, so if you are going to factor out now the common factor, it is going to be x plus 1. Okay, so this is our common factor. Okay, right, and that is x plus 1 to the power of 3. Okay, this is our greatest common factor. So the remaining factor for the first term will be x minus 1 times x plus 1. The remaining factor for the second term will be negative 4x times x minus 1. And for the third term, the remaining factor is negative x times x plus 1 to the power of 1. Okay? Now, why did I do that? So that we can cancel out the common factors between the numerator and denominator. And in this case, it is x plus 1 to the power of 3. And our numerator now, if you're going to combine similar terms, simplify the numerator, expand it, it's going to be negative 4x squared plus 3x minus 1, and then all over x minus 1 squared times x plus 1 to the power of 5. So if you further simplify it, the answer, our gradient function, looks more simple and better.